Hi, students. Welcome to video 24 on sewage treatment. So you either are connected to an actual sewage treatment system or you have a septic tank. If you don't have a combined sewer, then you have the septic tank. This is a specific place for either your house or a series of houses that are really close together. It basically empties down into the ground into a tank. You do have to empty it every year. It will fill up with your household waste. You also have to change old tanks every once in a while because the tanks will crack. They can leak different bacteria into our soil, which can then get into our water quality. So if you're on a septic tank, you just want to make sure that it is working properly and you're having it emptied every year. So if you don't have a septic tank, you more than likely are hooked up to a sewage system. This is for basically any homes that are in really densely populated areas. So if you live in the city, you would have a sewage treatment facility. And the purpose of this facility is to remove all of the impurities from the water and then put it back into the water cycle. So we actually want to cycle this water back into our rivers and streams. So we're physically going to remove solids, and we're then going to use biological and chemical purification methods to make it where the water is drinkable again. So this is an overview of the process. If I were you, I would pause and actually print out the slide, at least this slide, or draw it or whatever you need to do. It's better to have this with you as we go through each of the processes. So we're going to start with primary and work our way down to tertiary. So primary treatment is a physical process. You are basically moving this water through a filter, almost like a coffee filter when you guys were filtering out your pollution or your dirty water. Any solid particles are going to be removed. So things like paper, food and hygiene products, any plastic items like toys that got flushed down the commode. This is where we are going to then wash those products. We're going to dry them, and we're going to send them to a landfill to be disposed of that way. Then you're going to remove grit and sand with settling tanks. Basically, the water is going to sit there and all the heavy stuff will go to the bottom, and we can dispose of it that way. Also, in the primary treatment process, we can apply flocculants to the water. So these are chemicals that have a positive charge, and mud and water and dirt are naturally going to have a negative charge particle. Or the particles are going to be negatively charged. So those positives are going to attract the negatives, and then they form these big clumps, just like you see down here. Now these clumps can settle out, so they're heavier now, so they can also settle down to the bottom, and we can basically scrape. Imagine a big kind of like, ice cream machine or something like that, where there's a scrape blade going along the bottom, and it's scraping out the solids. 70% of your solids are removed from these settling tanks. We can then actually use that solid material. We call it sludge. Once we treat it with sludge treatment, we can then use it on farms as fertilizer. So sludge can be a fertilizer or a soil conditioner. And you do have to add treatment because it is still going to have bacteria and things like that. So we do anaerobic bacterial digestion here. Anaerobic means it does not require oxygen. So basically you have these huge digesters that are not going to have oxygen, and that's where the bacteria is. The byproduct of this digestion is methane, which would be bad if you're not using it to then heat more sludge and to continue the anaerobic bacterial digestion of sludge. So the methane, though, if it's not being used, is going to be a greenhouse gas that contributes to climate change and global warming. So the secondary process is a biological process, meaning that we're using biological organisms, bacteria, to break down the remaining organic material. So this is where the bacteria are added to the water. This is kind of where the smelly stuff is. If you ever go to a water treatment facility, you can see kind of it looks frothy and just kind of gross. So that is the bacteria. That is where it's breaking down this waste that's in the water. So the rate can be increased with aeration tanks. Aeration is adding water or adding air to the tanks. So a lot of times you'll see we're actually physically throwing water up to add air. And what this also does, besides adding air and oxygen, is it removes dissolved gases that are in the water. So these are the things that oftentimes make the sewage smelly. So if you can remove those gases, you decrease the smell. Then you're again going to use settling tanks after this process, because you then can settle out any material that now has been basically clumped together again from this process. And finally, we're going to do tertiary treatment, which is a chemical process. Now, not all countries do tertiary treatment. Most European countries do not. Here in the United States, most of our water treatment facilities do tertiary treatment. We can either disinfect with chlorine or ozone, or we can just use UV light to try to clean our water and disinfect it. So again, this is a picture showing you, here's the primary treatment. So we had the screening process in the settling tank. Then we sent it to an aeration tank and we settled it again. So settling is part of primary and secondary, and tertiary is going to be that disinfectant. Another thing we can do is use wetlands to treat sewage. So wetlands naturally do this process. They basically act like water filtration systems like you guys built. And we can make wetlands kind of artificially and then build them in our sewage treatment facilities. And so the wastewater can flow through all these different levels of the wetland, and that sediment, the plants are actually going to be soaking up some of those contaminants. So what happens if organic waste gets into a body of water? So if it's not moving, that's really bad. It's probably not going to clean itself. A lake will just settle. But a river can actually correct the pollution issue. So this is what we call an oxygen sag curve. You should have had this picture in your concept card. So here is our source of pollution. It is a point source. This is a drain. Before the pollution, we had low biological oxygen demand, also called biochemical. We had high dissolved oxygen in our water. Once we add the waste, my biological oxygen demand increases exponentially, or really, really high, because I added waste to my water. When I add waste, that means that my biological materials, my bacteria, are going to then start to accumulating, and they're going to be breaking down that material. So that's the reason why you see your dissolved oxygen start to go down, because the bacteria are now breaking down the waste and using up oxygen in the water. So your septic zone is going to be your area of lowest oxygen. And then once you actually can get rid of all that waste because the water is flowing, your oxygen will start to increase again back to the clean zone after the recovery stage. Excuse me. So again, these rivers can correct the pollution, but not so much for lakes. So what if we don't have water treatment facilities? Not everybody does. Some simple ways that you can purify water is you can expose it to heat and UV rays. You can heat up the water, boiling it. That's what this does. You can also filter water with cloths. So this is kind of what you guys did, but again, it will not necessarily take out the bacteria. But you can add small amounts of chlorine to your water if you have that available, which will purify and clean the water. You can also use carbon filtration. The ancient Egyptians actually knew about this process, and they figured out that it sanitized the water. So activated carbon can do two things. It can absorb organic compounds, because these compounds are so large, it basically can filter them in and trap them, kind of like what this picture is showing you. Or it can do catalytic reduction. It can attract the negative contaminants to the positive activated charcoal. Your Brita filters and refrigeration filters are usually going to be using this carbon filtration system. But again, not every place is going to have waste treatment. So in developing countries, it's very minimal, or there is no waste treatment. Most developing countries also do not have laws associated with sewage treatment, so you can just kind of dump it wherever. In India, about 2/3 of their water resources are contaminated with sewage, and 54 of the 78 monitored rivers in China are also contaminated. Now, that doesn't mean that the ones that are not monitored are not contaminated too. They probably are. We're just not monitoring them. So that accounts for about 1.3 billion people on the planet that do not have sewage treatment being done in their area, which means that they are drinking water that potentially has had sewage dumped above stream, from them, and they're drinking that material. All right, that's it. Bring your questions to class.